you gonna start talking?
All right, everyone. Welcome to Hacker Dojo Lightning Talks. Welcome. We're about to get started here. Raise your hand if you're here for robotics. We got, there's only 2 people that raise their hand. Okay, that's fine. All right, welcome to Hacker Dojo. If you are a guest, make sure you guys sign up at the front desk. There is this device here. Go ahead and put your information in there. You get a nice little name badge. So we get to know who you are. So welcome. All right, really quick. How long have you been here? Is this your first time here? Raise your hand. Okay, 1, 2, 3, 4, 5 people. Welcome. If you've been here more than 1 week, raise your hand. Okay. Oh, 1 month? Yay. 1 year. Oh, just getting here? 10 years. Hey, all right, cool. All right, 100 years. All right. Okay, are you a hacker? Raise your hand. Okay, we got a bunch of hackers in the house. Awesome. And again, YouTube, they tend to hang out on this side over here all the time. Developer. If you're a developer, raise your hand. Cool. All right, spread out. Entrepreneur. Just about everybody, right? Yeah, hobbyist. That's me. I'm a hobbyist. Like to tinker with stuff. Cool. Welcome. All right, Hacker Dojo is a nonprofit. It is a community of engineers, artists, scientists, activists, entrepreneurs, and other creative people centered around a co-working social facility. We're a nonprofit, and without the support of the members, we would cease to exist. So if you want to be a member, you can sign up there at hackerdojo.org. It's about $150 a month. We would really, really appreciate it. Do we have any Hive desk available? No. We're all sold out of Hive, so congratulations, Hacker Dojo. We have filled up. Ignore that, okay? Ignore Hive. We don't have any more desks, okay? If you're here for the desk, until next time. All right, current members of Hacker Dojo. This is just pretty much a copy and paste from the website. Make sure you guys go to the website so you guys can see that. If you guys want your name promoted on the website or even here at Lightning Talks, and you guys are in-house, you guys are a member, let us know. We'll get you some promotion on there, okay? Volunteers. Again, this is a nonprofit, so we do rely on a lot of volunteers. If you guys want to volunteer for Lightning Talks, please, man, fill my shoes. Come up here. I need somebody to come up here. It would be nice. I would like to sit down and watch somebody host Lightning Talks. It'd be great. Yeah. I would like to present something on blockchain. Right? Yeah. All right. Volunteers needed. Donations. There's a QR code. Everybody take out your phone, scan the QR code. Donate $5 right now. Thank you. Goes to a good cause. If you have spare change in your pocket, there is a tip jar. There it is on the desk up in the front. Donations needed. There is some physical items here. Like if you have a coat rack sitting in your garage, you got a phone booth. I don't know why you would have a phone booth in your garage, but if you have a phone booth in your garage, bring it over, all right? You got some plants, indoor, outdoor plants. And this list, by the way, is at the front desk. You guys can take a picture of that and go search through your garage or your storage. All right? Let's see, upcoming hacker events. If you're not checking the meetup.com website, /Hacker Dojo, I just copied and pasted the events that are coming up next week. So on Monday, we have 3H, Hardware Hacker Hangout. Okay? We got quiet all of a sudden. Tuesday, we have Python Meetup. Wednesday, Data Structure and Algorithms Meetup. Thursday, we have Rust Meetup. And again, Friday, Lightning Talks. Upcoming next week. Wow, it's so quiet in here, I'm scared. Hacker Dojo links. If you guys want to join the Discord, here's the QR code. You guys can scan that right now.
I have an announcement. On the 25th, 26th, and 27th, we're going to have a hackathon.
Yes! I wanted to talk to you about that. Okay. Make sure you get that on the calendar, all right? Because I was looking for that. Literally 2 days ago, I was talking to my buddy. I was like, hey, I want to try this out, man. Yeah, the hackathon. Say it again.
So it's going to be here on Friday the 25th through Sunday the 27th.
Okay. Friday 25th through Sunday the 27th here at Hacker Dojo.
3 weeks from today.
3 weeks from today. Did you have a question? Anything?
August 19th, video game ultimate video game party.
Yeah, that's on Meetup. Yeah. Yeah, the hackathon's not on there yet. Right? Hopefully everybody scan that. Join the Discord. Meetup, website, YouTube, Twitch, Slack, Discord, and Twitter. All the social medias there, right there. All right. I'll leave it up for another second. I see some phones out. Okay. All right. Cool. Group photo. If you guys want a group photo, please remind me at the end. So we'll take a group photo, all of us, in the back there. At the end. I always forget. Oh, that's right on. Let's try it. Let me just do that right now then. All right. All right, get ready. Okay. That didn't sound too exciting. All right, cool. And rule number 1 is, what's rule number 1 there in yellow? Oh my goodness, you guys know it? You guys must have been here before. Yes, be excellent to each other. Our speakers are going to come up and talk about robotics. They have 5 minutes to talk. And if they go beyond that, we're going to send them to the dungeon. Dun, dun, dun. All right, with that said, let's go ahead and get our first. We got a full board today. We got Robert, David, Nick, Joe, Anthony, Kevin. Was it Yaga? Let's see. Balaji, TJ, Siet. That's a full board. Okay? Don't fall asleep. A lot of stuff coming up. With that said, let's get Robert coming up as our first speaker. Welcome, Robert. Was that for me or for Robert? All right, so you want the adapter? Right?
Yeah. No, I don't.
Okay. This one here.
All right. Looks good. How to get into robotics. Yeah, so my name is Robert. I teach, I've taught robotics, I've taught electronics up at Noisebridge, down here, every single Monday for many, many years. Sans pandemic, but we'll get onto that later. Every Monday, we're going to be doing a workshop in here for robotics, and that's it. Anything else we need?
Take it out.
All right. Welcome. I'm going to try something different. Welcome, everyone. I want you to gather around as I share a mesmerizing tale that begins with an encounter so extraordinary, you're going to think I'm off my rocker. One serene evening, a majestic tree from space descended before me. It sought wisdom about robotics. I told it I would be honored to guide it on its quest. I said that the journey into the world of robotics begins with a single mouse click. Finding knowledge from the vast resources available from the internet. Free courses online, tutorials, and data sheets. Yeah. That explain fundamental concepts and fine details. Now, you must gather a little bit of information every day, I told the tree. Immerse yourself in the salt of the earth. It asked how we actually do that. So I led the tree into a field of wheat. I said, think of the movie Gladiator. You're walking through the field. Every single seed is a point of information. How do you know which ones to get? How do you know which ones to gather? And I asked the tree, well, okay, that's out of order. I asked the tree, if the world was so peaceful, why is the tree here trying to figure out how to work with robotics? The tree said they had been at war for a long time, but they finally learned to work together. And now they needed robotics to help reseed the planet with more trees. I asked jokingly how the rocks feel, the trees wanting more land. The tree sighed, well, the rocks are definitely beside themselves. One direction is a hard place, and the other was to work together. Now they support us while we keep them safe from erosion. As I led the tree out into the field, I explained why having a stated purpose is really important, e.g., repopulating the planet with your species. So I said, look, each seed is a piece of knowledge. Even you do not live long enough, great tree. Even you do not live long enough, great tree, to go through every single seed, because each seed is a kernel that is infinite. I told the tree to plug its roots into the ground plane and find the shell of any kernel. Now, let the flow of curiosity, the direction of purpose, and the daily determination to find the right seeds in this field guide you towards a solution. Each kernel you choose to focus on will add a feature to the robot that will help you reseed the plant. The tree found its shell. But after some time, it said, I'm a bored tree now. I have not cracked the kernel. So I invited the tree to come to the hackerspaces of Noisebridge and Hacker Dojo and Maker Nexus. After studying its bark off to achieve mastery in a few core things, with the support of a group, the tree did not bow out. It learned to solder. When it got frustrated, I told it to make like a leaf and go out and walk into the wild and find examples of how nature solves problems. When it came back, the clacks on the keyboard were so loud it sounded like a chainsaw. Finally, it produced code it was proud of, and which others could help the tree maintain. It broke off all the small, unwanted sticks and leaves, and with wood glue, patience, lots of tweaks, running sap, it built the robot that would save its species. As the tree got ready to go, it said, I hate to see you leave. It asked if it could leave a seed here on Earth, and I said, of course. Please go and have your way with our forest. It went, came back. Saying it was done, I gave the tree a hug, and it wished it well on its journey. That's how you get into robotics. Be like that tree.
Wow. That's a way to start it. Boom. All right, Robert, thank you. We got next speaker, David. All right, voice with internet. Oh, sorry, intent. Intent. Sorry. Intent.
Yeah, go ahead.
Okay, David, are you first time speaker here?
Yep.
Yes.
Oh, beautiful. All right, do us a favor while you get set up there. You can give us a little bit about your background and what you're doing.
Oh, mouse doesn't work.
Mouse is working. It's just you have a secondary window here. Look,
Huh?
You got to move your.
Oh, there's a second window.
Yeah.
Cannot be.
That's just how it is. It's just the device. So you got to slide it over to this one.
Oh, now what?
Grab it, move it over to this.
I have to come back to here, but I don't see it. It should be a single window only. It works inside. It doesn't work here. So now what?
Grab it. You have to move it to this monitor here.
But I don't have any cursor.
The cursor's on this window. You got to move the cursor back over here to this window. There you go. There you go. No. Go back. Keep going. There it is. So drag it, and then there you go. Now it's over here.
Okay, I have to make it bigger.
Mm-hmm. Good.
There we go.
Okay. So my name is David, and I'm a double E, and in my spare time, I just make things and solve problems. So that's basically. Okay, so first, I want to thank Robert from Hacker Dojo giving us his time and his hardware so that we can build something. So I also want to thank the team putting in the hard work to get to where we are today. So this is our robot about 2 months ago. And this is in the dance mode. So what we have done is we utilized the LED and we added a servo to control the servos so that it can make all those motions. The only thing that we didn't use on this board was the microphone and the accelerometer. So after we finished this stage, we decided to do something else, but we didn't know what to do. But we came up with the idea, why don't we put voice onto this robot so it can respond to our voice. So this is the main board. It has all the components that we require, the accelerometer and the microphone. So one night we decided to put voice. So we did about 2 hours of research, and most of the stuff is like Amazon and Google. So most of the from Amazon and Google, it requires you to hook up to the cloud in order to recognize the voice and then give you feedback. So then we decided to move all our motion controlling from the core board onto this small board from Raspberry Pi, and it's a $4 board. So with this intent, we started to do some research, and we came up with Pico Voice. And from Pico Voice, there is multiple platform, and we can use a no-code method. And all we have to do is go on to the Pico Voice console, look up our board, specify the language, and upload the firmware. So we upload the firmware to the board. In that same night, we got all the code working. So when we say the wake word and tell the LED to turn on, it did. It did turn on. So it was just amazing to us. So that was that one night. So the next time we come back on another Monday, then we get an account from Pico Voice to get the access key. So from the access key, we go to the GitHub to download the demo program. And from that demo program, we have 2 files that we have to modify. One is basically 2 data sets in one file. We need to put in the wake word and also the intent. So just 2 data sets. And you can get different data set by download from Pico Voice. And you can train for other intent. And training is very simple. All you have to do is type in the text. Type in a sentence, and it will give you the data set. So the other file that we have to modify is the main.c. So we have 2 callback routines. One is the wake word callback, and the other one is inference callback. So we can put in anything in there to do what we needed. So we did the 4 types of action that we can do. Right now it's only the dance and walk, but we could do the sit and bow by creating these commands that we can tell the motion board to perform the motions. So a good example of what Pico Voice can do is we can say, Pico Voice, can I have a small double shot of espressos? So with that, when it come back on the callback, it will tell us whether the sentence was understood, what was the intent, and what was the the slots. That's what they call it. So it was very simple. So these are the platform that it can accommodate. These are the language currently in use. The dark color one is the one that's already available. Light color is to be done. And these are the company who's looking into Pico Voice.
All right, David. That's awesome. Thank you. Questions for David? Any questions? No? No?
You said bow and walk.
Yes.
What, is this an animal? We said bow and walk. Is this an animal?
Well, the dog can sit.
Well, we give him a dog. Right?
Yeah. So
Look at it.
yeah, we have a demo if someone want to look at it because it can only set up on the table. So
All right, David. Thank you.
okay, thank you.
Next speaker we have Het. Kinematics. And while Het comes up, he gets set up. Just want to let you guys know that pizza is here. So if you guys want to grab some pizza, you guys can go to the back right now. Grab you guys a couple of slices. You guys can donate Venmo or Spare Cash. There's a tip jar. There's a Venmo QR code up there. It'd be great. You guys can help cover the cost of the pizza. All right.
Wonderful. Can I get started? Hi, my name's Het, and a bit about myself. I graduated high school last year, and I'm going to college for aerospace engineering. I started coming to the Hacker Dojo a few weeks ago, mostly because I was just interested in the robotics part of this, because I came from a strong robotics background. And one of the problems that we had come up with was we needed to solve for the position of the end of an arm, right? And I looked into it, and it turns out that's called kinematics. And most people see that word and remember high school physics and a lot of really bad grades. Well, I'm here to fix that. Kinematics, when it comes to robotics, doesn't actually mean the physics of an object, but it can. In this case, what we're trying to solve for is linkages and how they interact with each other. And given a set of input angles or input lengths, we can figure out the position of an end effector or the end of an arm. And the reason you'd want that is because once you have the motions of equations for an object, you can work backwards. Like, let's say I wanted the arm to be at point A, and let's say it's currently at point A, right? And I wanted it to go to point B. What you can do is you can solve for the inverse kinematics. Like, naturally, as a human, we've evolved to learn that I need to retract this muscle by 4 inches and extend the other one by 5 to go from here to there. Well, how do you program that into a robot? You have a few options. You can create a physics simulation, but that's really expensive to do on an embedded device. But let's say if you solved for the kinematics equation, you could eventually turn something like this diagram into a really simple function with just a bit of trig. And this is the exact arm that I had solved for here. We had 2 input servos, which would drive these 2 arm lengths here. And the way how you'd solve for it is just a lot of trig and angle rules. Because you can turn this into an imaginary triangle, and since you know the end position of this and this, you can solve for that length. Kinematics in and of itself isn't useful without a goal. And in this case, the goal is to get the robot off the ground and moving. So when we had an idea of what thing we needed to know where the end was, and to know what the inputs were, from there we could work out a motion equation of motion, plug that into the Pico, create wrapper code around it, and then eventually call that from the STM32 to allow us to move the robot around. The exact way of how that worked is a bit detailed, but yeah, that's kinematics. Basically, we're trying to solve for the movement of an object and how it moves and how to get there.
And I think that questions about kinematics. Okay. Questions. Over here?
Oh,
we got one.
we
We
have
got one.
I don't want to make it too many nitty-gritty details, but if those two on the bottom were active servos and the three up top are just joints, wouldn't it need to know the relative difference in friction between them to know if you move this servo, where's that movement going to be taken up? How complicated does that get?
You actually don't need to know if you know the angles down here, because it ends up being a fixed system. Because even if the arm, like, you can see how there's two joints here, right? And you know that it's uncertain whether the angle's here or there, and whether this link is here or there. But in the end, it doesn't actually end up mattering where there's friction, or if we're pushing against something, because we're not a physics simulation. We're just trying to solve for the end position, and we don't need to do those physics iterations with friction, drag, or gravity.
Any more questions? Okay. You said you just graduated high school, right?
Yeah.
Dude, that's amazing, bro. That's crazy. Like, what? What? Are you a robot?
No. Kind of wish I was sometimes, but no.
All right, thank you. Thank you. Next. Joe, Robot Red. Come on up. Again, there's pizza in the back. You guys have enough pizza. And if you guys want to help donate for pizza, there's a QR code over there. And that's it, John.
Mm-hmm. No input signal? Okay. Let's see. No signal. What's that about? Is there another input or anything? Maybe I can try a different one. Try this one. Let's see if this works.
Give it a second.
Mm-hmm.
Yeah, try the this one? Try this one.
Not working? Okay. Well, I can talk. I guess I have no pictures, unfortunately. So, okay.
Let's see what happened here. Mm-hmm. Are you able to send this in the server?
We can switch somebody else in. I'll get you set up.
Yeah, you want to do that?
Okay.
Just switch? Okay. Let's go ahead and do a switch real quick. All right, let's get Anthony coming up. Precision farming, and then we'll get Joe back up.
Hello. How's everyone doing tonight? No, I gotta hear a better response. How's everyone doing tonight? All right, I'm gonna kick it off with a joke. What type of music do robots like? Good guesses. Heavy metal. All right. Oh, yeah. Why did the robot get angry?
Why?
Because someone kept pushing his buttons. Come on. You guys are supposed to be all robotics freaks. Come on. All right. For those of you who don't know me, I'm Anthony Moose. I'm the founder of Ageless AI. I have a medtech and longevity startup. That said, I'm going to talk about my personal experience as close as I got to the robotics industry and the industrial agriculture, specifically precision farming and autonomous tractors, which I think has probably the most real-world use cases and affects every one of us, since we're all eating pizza right now. So there are 8 billion people on this planet, and there's less and less available land to farm. In fact, there's less than 6% of land to farm, to grow crops, wheat, and so forth. This is an industry that can only be solved by robotics and artificial intelligence. In order to yield the maximum and efficient output, there's no other way around it. So some years back in 2018, I had done some work with CNH Industrial. John Deere and CNH Industrial are the 2 leading companies in this field. They had flown me into the headquarters in Illinois. At the time, I played a bunch of different roles, but primarily a performance data scientist. I was alongside a lot of professionals and leading engineers across robotics, AI, computer vision, data science, DevOps, cloud, mobile, you name it. And this is not easy. It's actually a very, very noble profession because you have to do things efficiently. And how does that happen? Oops. Click the wrong button. Bear with me. Click the wrong button. All right. My bad. Sorry, a lot of technical difficulties here, or kinetic difficulties, I don't know.
The front should pass by midday. Based on drainage, and when the rain stops, we should be able to start spraying by end of day.
Yeah. You on his way there?
He said he was checking on the boys.
All right.
And thank you for coming to my lightning talk.
All right, questions for Anthony? Oh, yes, we do have a couple here. Let's go with the gentleman first.
Quick question. What program did you do that presentation in? Just curious.
Keynote.
All right, next question.
So, at what stage right now is your enterprise in precision farming right now?
My venture is in medtech and longevity. My company is Ageless AI. This is some work I've done back in 2018. That's as close as I got to real-world robotic applications.
I see. Thank you.
So what was your role in that?
So essentially, these autonomous tractors cost about $250,000. And my role was to do a lot of load testing and performance testing between the satellites. The farm owners will have tablets that control the machines, and all the machines and sensors and everything. So we're talking probably like around 200 APIs that had to do a lot of DDoS attacks essentially until they failed and find the loopholes. I also found some other security loopholes. So I found some, anyone familiar with GPS spoofing? So I kind of told them a security vulnerability where if I gave them the right longitude and latitude coordinates, I could take that cool robot and just, you know, take it over to my farmland and probably trade it for a yellow Lamborghini or something.
Yeah, actually, so I'm curious, did anybody actually adopt this? Because I used to work on a drone project myself in 2018 with autonomous drones in ag tech, and what I noticed was it was really the pushback was from the farmers themselves not willing to learn the technology and adopt it. So I'm curious if they actually broke the ground with that.
Let me ask you a question. What size land do these farmers have that you're familiar with?
I don't remember off the top of my head, to be honest.
So when it comes to industrial agriculture scale, we're talking 1,000+ acres. And most of these people are going to be using that. It was pretty much launched 2021. Yeah, maybe 2020. Yeah. John Deere, CNH Industrial, you can look them up.
All right, Anthony, thank you. All right, we have Joe back on. Is he good? Robert, do we have Joe back on? Not yet? Okay. All right, let's get Kevin. Kevin, robotics EV charging. Ooh, all right. Welcome. And you can just have that on there. And just do us a favor, give us a little bit about your background, who you are, and what you're doing here.
Sure. My name is Kevin Cameron. I normally work in semiconductors, EDA tools for chip design, design verification, that kind of stuff. I've been trying to do startups for a number of years. And the current startup I'm looking for people to help me with is robotic EV charging. So this is going to be a small robot. And the idea is that you use a bunch of them and they move energy around for you. So they move solar energy from building the goal. I maybe have somebody signed up to do some robot design. If anybody's interested in programming the robots or software around how we manage a whole pile of robots and watch where people's cars go and try and work out how to make money out of it, that would be good. So if you're at all interested in hearing more about what the plan is, like you can find me and ask me questions if nobody wants to ask now. You can dig into detail if people like. You want some more? Yeah. Okay, so the target robot here is like $3,000 in production. Yeah, sorry. Yeah, so the idea is to build a robot at about $3,000 price point. Something that looks like a robotic lawnmower in scale, overgrown Roomba. The target market is going to be things like car parks, park and drive kind of thing. If your car's sitting around for the day in the car park, we're going to be picking up energy from a building somewhere and then going to cars and pumping the energy in. Cars probably aren't equipped for this initially, so we'll probably give people a dongle which will plug in, hangs down somewhere, and the robots actually attach wirelessly to that. So we could also do with a power electronics person if that's not around here. Anyway, if you look at what's happening with cars, we spend $1 billion a day in gasoline. That's probably going to run into several $100 million of electricity in a decade or two. So my goal is to get as much of that business as possible. So if you want to get in at the start, there's the time to bug me about it.
All right, that's Kevin with Robotics EV charging. Question?
Kevin, let me repeat, see if I understand. Are you saying you want to make a robot that's going to go, let's say we're in a parking lot or someplace, the robot comes out to the car?
Yes.
And I'm not, there's nobody there, but I've signed up, let's say from an app or something, and I'm saying I need power, your robot will come over, connect, and deliver?
Yeah, you probably don't even need to sign up much for this. We'll give you a dongle or something, and the robots will just fill cars.
But the main point I want to understand is, we're not out at the car. Your robot will go out to a car or truck and charge it out the roof without anybody around. Is that the idea?
Yeah, it's fully automatic.
Okay. And how about things like opening the...
We don't do that. So the secret sauce, so to speak, is wireless connection. So my background is power electronics. So
you can deliver all that power wirelessly?
Well, 60% of trips are below 6 miles. That's about 5 kilowatt hours of energy. So we're looking at topping people up over this. So we want people to start off the day with car half full or something, and we top it up over the day. So when you get home in the evening, the car is full, and then you can use that energy to run your home. Anything spare, we can sell to the grid at that point.
Okay, so it's like a top-off service, but the point is it's wireless.
Yeah. We could do fast charging as well. I mean, it just depends how many robots you want involved. The idea is it's bucket brigade. If you want more energy moved, to get more robots.
Okay, gotcha. And how far along are you so far?
Have a pending patent, and I have 2 or 3 people on the team.
You have a prototype yet?
No. Okay. I mean, there's a lot of what we call AMR, autonomous mobile robot platforms. So we get one of those, and then I was talk to somebody today about getting an arm for the wireless connectivity going. So it's mostly subcontracting people to do stuff to get this going, but I will need people to do software and some of the power electronics design.
So for all the parts you need just in developing your prototype, how much do you figure cash you need for the parts?
I think the minimum viable product's probably somewhere about 400,000 to $500,000 to get something working. And then your problem is trying to get through UL and things like that.
Thank you.
All right, another question? There's another question? Here you go, hold on.
So the robot has a big battery inside?
The idea is that the robot only has a small battery, so you're looking like a kilowatt hours worth of energy, or maybe a super cap.
Perfect. All right, that's one more. Oh, here you go.
Just want to confirm, the wireless charging, is that some technology that you guys are trying to develop, or that's some other third-party companies maybe developing and you guys want to try to incorporate into it?
I'm going to try and get a resonant link to do the transformer piece for me. They've got better technology, so it'll be 98, 99% efficient going that way. I haven't managed to get a conversation going with them yet.
All right, Kevin, that should do it. Thank you for robotics EV charging. Awesome. Okay. All right, now, okay. Joe's ready? Robot footage. So bring on robot footage. And again, Joe, before you get started, just a little background.
I'll set up. My name is Joe Buffkin. I'm a mechanical engineer. Most of my time was in Houston, Texas, with NASA and the aerospace business, designing stuff that astronauts use, that kind of thing. So a little bit of propulsion. But I always wanted to build robots, so during the pandemic, I took the opportunity to work on one. This guy here is named Fred. Friendly robot employed domestically. So, of course, NASA, you always got to have acronyms, right? So here's where I started. Here's there was like just. Oh, I'm sorry. I'm always doing that. Here's the base I'd started. I actually had this machine for me, designed and had a machine, and you can see the motors and the wheels. So that's just the base. Whoop. Okay. So here's the motors doing a little bench type test. When I showed this to my daughter, she said. When I showed this to my daughter, she said, "Looks like you're just spinning your wheels." So, which I thought was great. Here's another view of the superstructure, and you can see some of the the 3D printed parts that are going as part of the base. It covers up some of the stuff. And then here is Fred actually navigating in and off. You see he's got LiDAR on the front there. And I'm using ROS 1 for navigation. This runs on with the Jetson Nano as the main brain for this thing. And it got where it could navigate a little bit, but as I'll talk later, it needs some work. Here's the robot arm doing some testing with that. I'm going to advance. There you can see the arm, and the arm is moving very slowly right now. It's just controlled directly from the computer. There's a lot of work still involved in getting the arm to work also, and getting it to doing the kinematics, as someone said earlier, which can be very complicated. Luckily, there's programs that can figure all that out for you. Okay. So let me see if I remember how to do this. All right. Okay. So Robot Fred up for adoption. So I'll tell you what that means in a second. Let's see. Okay. Okay, Rob, how do I get this to scroll? Let's see. You told me. All right, here we go. Okay, I tell you, the background story on this is I initially designed this to be an assist, a caregiver responsible for elderly, providing a remote communication link, a bit of companionship, and some actual help, like maybe go get me something to drink, that kind of thing, using a voice command, which is another thing someone talked about tonight. It's a dual-wheeled robot. He's able to navigate a little bit. Next task is to get the arm working, provide object recognition, navigate. 3 years of work, much development, some money. So the status is the navigation software runs last navigation on a Jetson Nano. The arm is in early stages of development. Needs a lot of work more to get that going properly. The communication vision software not really started yet. Mechanical problems, arm mount improvements, a battery mount, board mount, many other improvements. Too much to list. I have a whole list on a project management listing. Electrical, install cooling fans. Well, you can read all this. Improve electrical connections. There's just tons of things to do, as you might expect. So why am I here? Okay, what's the deal? Fred needs a purpose and a home. If not found, Fred's going to be moved to storage, to a robot shelter. And so Fred is available for adoption to the right person of the group. I'll be glad to be involved in transition to a good home if you know of one. So if you want to get in touch with me to talk about it, please do. So that's it. Thank you.
All right, Joe. Thank you. Questions? Is this question, Joe? Ready? Is this a precursor to the T-1000 Terminator?
I can't talk about that, in this forum. So.
Where's John?
Hi. Actually, I come from a hackerspace in San Francisco called Bridge. And I actually am trying to start a robotics group there. I know how to use ROS and with a lot of, I'm getting a turtle of my own. Would you be open to doing it for hacking or like robot group hacking purposes?
Yeah, get in touch with me and we'll talk about it and see what we can work out. That's a possibility, yes.
Is somebody's robot about to self-destruct? What's going on? Question?
Does it support Rust 2 or only Rust 1?
Right now, mine is running ROS 1. Yeah, ROS 2 would be an upgrade. And shouldn't really be a big problem to go to ROS 2 if someone that really knows the ROS.
Another question in front?
Should your robot gain consciousness in the future, how is it going to feel about being put up for public adoption?
I don't know. When I get done with the time machine I'm working on, I'll let you know.
All right, one more.
So this is useful for the elderly people to, I mean, it assists them. So is it fast enough to move around, or it is, you said it is very slow. How it will help to the elderly in case of emergency in the house, or does it have the power to pull them out? Or?
Oh, okay. No, this would not, as designed here, would not have the power to pick someone up. It's basically be able to pick up a glass of water. That's about the strength it would have at this point. And it moves pretty fast. Probably the slowest part will be processing commands to move, that kind of thing. Once it starts moving, it can move pretty fast.
All right, cool. Thank you, Joe.
Thank you.
All right, Fred, bring my beer.
Yeah.
All right, next we have, is that you, Yaga? Yep. Yaga. Case for Rust. And Yaga, just play a little background noise.
This right here should be. Where'd it go? Not there. Yeah. I also have a joke. What's on the robot's gravestone? Rest in peace.
Oh, no!
Okay, cool. All right, so I'm here to talk about Rust and a little bit about embedded Rust since this robotics theme. My background is worked in software development backend for a few years, companies like Uber and Meta. Currently in between jobs, so hit me up. I learned about Rust when I was at Uber doing SRE work, completely unrelated, and would just read the Rust book when I'm on call, and people would look at me weird. So now that I don't have a job, I can actually do Rust. So another joke is a Rust developer with a job. So I'm here to talk about a case for embedded Rust. Why would you want to do that? How many of you have not heard of Rust, the programming language? How many of you are okay at it? Okay, how many of you are Rust curious? Okay, good. So Rust is a systems programming language made by Mozilla and now developed by the community. 1.0 was released about 9 years ago. My current focus in Rust is testing and hardening WebAssembly runtimes. Some of the work involves creating grammar-based fuzzers in Rust and finding obscure bugs in WebAssembly runtimes. So not robotics related. And I came here to Hackadojo for the first time a week ago to the Rust meetup and met Rob, and he said, hey, it would be cool if you can put Rust on this board right here and talk about it next week. So some buzzwords you might hear about Rust is fast, reliable, productive, pick 3. This tagline sort of captures the essence of Rust being a modern systems programming language. So where you have very good performance, but also easy to use tooling and newer sort of programming language innovations packed into one language. So some technical bits are Rust is a compile language. It's compiled down to machine code, not byte code. So that means there's no overhead performance penalty of a virtual machine or interpreter. It also has a very strong and expressive type system. So compared to C, which has a static but not expressive or strong type system, you're protected from a lot of runtime bugs. There is also no garbage collector, GC, and no runtime for Rust, while standard Rust does have a very small runtime and initialization code. You can build Rust for embedded without runtime. You can't really talk about embedded development without getting compared to C, so let's look at a couple of things I find Rust to be great at in that context. First is the expressive type system I talked about. Here's a very simple example where you have an option type of none or some, so that would be a thing and a null pointer. So the upside of this is you can never get null pointer dereference sort of type of bug in Rust. And the best thing about Rust compared to C, I think, is the unified dependency management and build system. So what that means is think of it as NPM, but for Rust. So you have easy to write and build modular code in Rust. And for me, it was super easy to get started with embedded development. So it's just a case of cargo add the board crate, which is STM32F3. And that's how I got started. Another popular language is Python. I know some folks are doing MicroPython right now. Rust's advantage there is it's run much faster than Python with a much smaller memory footprint. So in constrained embedded environments, that's pretty important. Also in Rust, you get neat and relatively new PL features like pattern matching and algebraic data type, like the option type I just mentioned. The result from a static type system is you get fewer runtime exceptions in Rust and Python. One thing that I want to talk about is Rust on the server versus, I just picked Go since I'm familiar with it. I prefer Rust over Go in this kind of environment. I've done server development in both Rust and Go. And one popular reason for people to move from Rust to Go is there's no GC pauses. I've seen that when I was at Uber, where they migrated from Python to Go, GC pause was a big problem for high throughput services. And so similar that you don't have manual memory management in both Rust and Go, but Rust does it sort of statically, and there's no GC tracing in the middle of execution. Yep. And if you're Rust curious, YouTube Considering Rust by John Jenset. He was a PhD candidate at MIT, and I joined Amazon because this guy went to Amazon, and I thought it would be cool to work with him. And then I left without ever having working with him. And also Google the Rust book if you want to get started. That's 5 minutes.
Woo. Thank you for that.
Yaga. Yeah, you got it.
Question.
Is there like an easy mode if I'm doing something where I don't care so much about performance and where I don't have to worry about the data ownership and the move semantics?
Yeah. I say easy mode is just use owned data types everywhere. So for like strings, you use the actual owned string data type and not use a string reference. And you can also get a very similar experience to Go or Python with the atomically reference counted data types like arc. You can wrap things in arcs. ARC, you can look that up.
Another question.
Yeah, so when it comes to Rust, what's the language support like for other embedded platforms beyond the STM32?
Yeah,
MicroPython is supported on a lot of places.
Right. So theoretically, you can use Rust on any platform that's supported by the LLVM toolchain. So I know that obscure ones like PowerPC, you can also do ARM, obviously. And yeah, talk to me afterwards. Anything on EVM you should be able to do in Rust.
One more question in the back? Robert?
I have some boards that have really small chips on there. Do you think you can run Rust on there?
Yeah, so Rust runtime characteristics are very similar to C. So anything you can put C on, sans the LVM restriction, you can probably put Rust on there. The memory overhead and runtime is close to C.
All right, thank you,
Thank you.
Thanks so much. Next we have Balaji coming up on stage, and he's going to talk about reclaiming bots. What I like is that so far no one's been sent to the dungeon. Everybody's been staying within the 5 minutes. To the dungeon you go.
Hello, I'm Balaji. I'm in IT as a consultant. I work in companies like Toyota, Genetech, and where I have seen robotics, actually. I took a tour in Toyota. There I have seen robotics arms making the Lexus cars, which they press and do all the parts. So I got interested in robotics, but I haven't done much in that, but mostly in software, but designing. So one of the idea was using the elephant's design, which is million-year-old design, how to use that for refueling station, like compact gas station, we can say. So you've seen the elephant is trunk is more very strong, and it can be flexible, which can be used for maybe charging hydrogen or electric cars, which can also move and refuel you with the coffee and things like that. So they just making the trunk as the vending machine to give that coffee or refreshing thing. At the same time, the trunk is used for fueling the current hydrogen or electric cars. So it has the card reader and also display screen as the ears we can use to display the different available items. And also the body can be used as a storage of the different beverages, things like that. So it is a compact fueling station on the move. So it kind of may not be fast, but just moves. So it has its meter to display the different design, and also scanner or another design. So this can be used as a car wash also, because you have seen the elephants, they do the washing thing very better on their own. So it's powerful jet. It can spray and wash. At the same time, it can use its trunk for cleaning liquids, shampoos, and things like that. So it can use its brush as ears, something, and a dryer as fans of in the bottom we have the fans. So it can be a car wash station. It is a multi-purpose type of an elephant, we can say. There's an elephant in the room, but it has its purpose. So we can use this as a mechanic helper in a way. It can store the liquid and can dispense different fluids according to the mechanics instruction, whether vocal or sign. It can bring in all the tools required. So it is another way of using the design of elephant. It can be a robotic nurse, which can give kind of saline or giving a display of different results, giving the right tools for the doctor. So yeah, those are the things this can do, but mostly on mechanical side, it is more safer because it's a robot. And it is, if you can use the thread, 4 thread can fit its legs. So it is possible to make. So at least we can use that in Burning Man Festival. They are using still the elephant. Thank you.
Question for Balaji. I don't know if I would have that in me. If I'm having surgery, Balaji, I don't want that elephant. Jesus.
So the first thing I thought about when I saw the elephant is you fill the elephant with water and you go out into like the Grand Canyon and help out hikers so you can bring enough water.
Water, yeah. It has capacity for 4 gallons it can drink at a time. So it can swallow a lot of water to transport. That's a good idea.
More questions? All right, Balaji, thank you.
Thank you.
Next we have TJ coming up. Woo. All right. TJ, welcome. And we're able to get set up and stuff and just a little bit of background and stuff. And definitely take some time to let us know what noise bridge is on. Yeah, what is noise bridge?
For sure. So the title, which I totally didn't make up in the past 10 minutes for this presentation, is Noise Nav. And the main takeaway of those two things, where's the HDMI? Oh, okay.
No, that's Mike.
Oh, that's Mike.
There it is, right there.
That's it. This is? No. There we go. Main takeaway is the main takeaway is that I'm from Noise Bridge, which is a hackerspace in San Francisco, and I'm essentially re-implementing Nav, the Nav2, like Nav/Nav2 framework with visual only. I will. Oh, is that the timer? The timer? Okay. Oh. Yeah, let me do that. Yeah, it's a really sick timer. Did you?
There you
go. Oh, there we go. I seem to be. All right. The idea is my idea is Noise Nav, which is visual only indoor no robot navigation. So why build a robot? I think it would be cool for a hackerspace to have like a tech fixture, mostly just like a robot that goes around and guides people to the space. I wanted to. I have as my background, I'm a software engineer, but I recently had studied and graduated with robotics, with a computer science with a robotics background, and wanted to get some practical knowledge too for a potential job. So this was originally presented to a more general AI audience. I'm sure everyone's familiar with this, but for those who don't know, this is what the robot stack looks like. I'm going to be focusing a lot on perception here, since this is like the main goal, and as well as SLAM. So SLAM is aka simultaneous localization is mapping, is if you're a robot in the space, how do you figure out where you are in the space, like what the space looks like and where you are inside of it. Two major implementations of this are the Kalman filter and the particle filter. For my plan for this is to use a particle filter setup, just because it's a lot easier and more robust to like movement updates, or like if you don't know that much about movement mechanics, or the movement of the vehicle. Yeah, so basically SLAM was something invented in the early 2000s, where you estimate where a position set of landmarks are. And you have there are two steps: the process update, which is basically how far did the robot move, and the sensor update, which is where are you with respect to a given set of landmarks. And a lot of people have used this via nav2. So this slide is basically like a lot of times in order to create a point cloud, it's like we usually use LiDAR. But what if you could use camera data? And the main goal, and like you've probably heard from most people in the robotics group, you've probably heard Musk talk about this. LiDAR is super expensive. People don't need to use LiDAR to navigate in a 3D environment. Why not robots? And indoor navigation means you like don't have a risk of crashing into things on the highway. The major problem is that cameras don't intentionally have 3D data, so you kind of have to infer it either from a stereo image or from visual odometry. But now there's a lot of updates in deep learning. So for example, they've actually done like deep visual odometry, and some things I saw, like for example, Meta is actually creating something, and Google are both doing visual like AI in robotics, with the Meta especially creating a representation learning, which is basically like encoding an image into a set of bytes that make it easier for robotic, particularly for robotic navigation. Additionally, there's a concept like with April tags and such of using 2D objects for landmark tracking. So yeah, I have a minute left and I don't want to get sent to the dungeon. So the onboard compute is Raspberry Pi 4B with about 4 gigabytes of RAM. I have a USB camera and I drive the motors through an H-bridge. And in order to do the heavy lifting, I'm going to go to a onboard computer, which has a 1080 Ti, also running Ubuntu 22.04 and ROS 2. And implementing an ultrasonic array for obstacle avoidance. So far, I have done a lot of the bring up of the robot itself, so it can move around, it can interact with, it can like do a calibration set, and yeah, and I can also like communicate between the Pi and the computer, and because the hardware bring up is going to be long, I'm currently looking at a Turtlebot 4, or I'm just buying that and using that for, and on parallel trying to develop the sensors like the Encoders Connect and the Raspberry Pi and Arduino. Also, here is the Noisebridge AI Discord channel. We also are on Meetup, and that's my presentation.
TJ, questions?
Yeah, that was awesome. I'm curious what you mean when you say 2D landmark navigation. What I'm imagining when you say that is you mark an X on the ground and then the robot knows where that X is.
Basically. So are you familiar with April tags?
No.
Okay, so April tags are kind of like QR codes. There is one, a couple down here. This is what an April tag looks like. It's very similar to a QR code, but it's essentially framed in such a way that it's like you can just kind of use like, oh yeah, this set of patterns is the April tag. And then you can actually, because you can put a pretty good bounding box around that, you can figure out where the position of your robot is with respect to this tag. And the idea is with segmentation and like mask RCNN and other thing, or like other like object detection and bounding box stuff being really accurate, you could theoretically do the same thing with any LiDAR. So like if you wanted to do it on this like Hack the Planet logo. So the idea is combining like your traditional mask RCNN with like a autoencoder that can recognize, basically something that can like recognize a distinct image. Yeah.
One more question. So for now with the camera, do you use like 2D camera, or you actually want to use like a 3D camera, like more expensive line, or you actually just want a 2D camera just to show that and you can like look
Yeah. Yeah, so the end goal is to use a 2D camera. Right now, when I talked about, like, for example, getting a Turobot, like this, I think the actual like custom built product will have just a 2D camera. Oh yeah. So yeah, the end goal is to have this 2D camera, basically on the robot itself, or like just a simple USB cam, and perhaps have some more, but like use monocular vision. I could use stereo. I might use stereo vision if I think the like 2D point clouds could help with like the visual SLAM algorithm. So yeah, I'll probably start with RGBD and then try and use monocular if possible.
Thank you for coming down from Noisebridge.
Thank you.
One more.
Oh, I should probably keep this.
So when you chose April 5 as your visual solutions, did you consider other platforms before you chose April 5, or was that just the one because it's easily supported by OpenCV?
Yeah, mostly because it's like a big, because it's kind of like a standard for fiduciary tags. That's why I chose it, and it's like compatible with everything. Yeah, but I eventually will want to like use like object detection to have like a custom fiduciary.
All right, TJ, thank you. That was noise now. All right. Not today. We got Smith, last speaker.
Get him. Actually, I do have a presentation which names artificial robot in natural resources. But because I already have taken 20 minutes of your time, my proposition is to give that place to someone else more valuable. So anyone want to take and make this speech right now? Startup, anything, anyone want a mic? Because again, I already spoke like enough today. So
pretty much.
Anyone take my place?
Going once.
Come on.
Going twice.
Yes.
Oh, we got a runner. Okay. Robotics? We got a robotics?
Yes. Come
on up.
Your mic.
Whatever. I come on.
I'm good.
There's somebody here that missed.
I can't believe that. Guys, that's opportunity. Give your pitch. Yes. Go. Yes, excellent.
Yeah, all right.
Yeah.
What is your name?
Edward. It's my first time here.
Edward, welcome.
I just happened to do during my undergrad a robotics project, so I guess I'll bring it out from my grave in Google Drive.
Edward, first time. Welcome.
Oh, thank you so much. Okay, sorry about that. I was checking out those page. Let's see. So this. Oops. Sorry, how's actually? So maybe just to showcase so basically let's see. Maybe I'll start off with the slides. Oh, okay, yeah. So yeah, so during my undergrad project, I actually worked with Professor Tori Proster and Simon Penny on UCI on like robotic herd, along with my colleague Peter Cho. Yeah, he actually did most of the programming. I'll be up like back then. I was just really interested, but I'm actually doing this as an art project. So we want to like simulate the movement of herd animals, but they want to implement like robots. So that's the overview. And then this topic is actually made by the professor, and as our undergrad researcher, we're trying to see how we can adapt this or making this even possible through engineering. Yeah, so our researchers, so we actually came across like back then. There's a algorithm called BIODS, BIODS by Craig Bird. They actually use it, I think, on more animation based. So actually the code is out there. So from this book, I think we just copy and pasted some of this. And yeah, it's quite interesting how it's able to simulate flock movement. So they divide it into three. Oh yeah, so over here. Thank God I have the notes. Alignment, separations, and cohesion. So alignment is how it heads toward the flock mates to form the group, right? Like a swarm. And separation is how they try to steer away, usually from like a predator or something to avoid collision, right? And cohesion is they try to stay in the same direction or something like that. Yeah. And like for some magic, I guess once you put all the vectors together, they form like the swarm movement like in nature. So here's kind of the, I guess I have the video later, so I'll showcase it later. And yeah, so we use OpenCV to map the robots, the coordinates. We actually got kind of like taught by the professors, like, well, now you're having a God element that tells the robots where the coordinates. So we're like, come on, this is as good as we can do. But yeah, we use OpenCV so far to locate where the robots are in the 2D environment. So this is kind of the setup. You see up there, there's this camera, and we actually just tied a balloon. For some reason, it's good for identifying onto the robot. Yeah, and then we just put like Vex robot part, and we did some simulation on it. I have videos. For some reason, it's not working. Yeah, and then I was actually more into the 3D modeling, so it's like terrible for the movements and there's some design. Yeah, I guess let's just hop into the video references if you don't mind. So here's actually the better version of the. So this one includes is done through Unity, and we can see like so the blue dot we're simulating like the predator. So you see like once it tries to chase like the flock, you see it starts to spread out. But eventually you see when it gets too spread out, they actually go back and form like separate groups, right? And if we try to navigate like the predator and toward the other group, trying to combine together, they will actually know, oh, we're part of this group. So then they start accumulating together into a group, yeah, which I find quite interesting. So now the hard part is how do we get it to work with robots, right? Now, so we did some kind of simulations on like the companions. So this is like kind of the simulation of following the robot. So right now the robot is targeted and has a coordinate system, and over here is like a target that it's supposed to follow, right? And yeah, with all the stupid gyros and I mean, all the coordinate system, it tries its hard. The white part is actually the head, by the way. Yeah. So we did like separate testings on like, evades and stuff. Yeah. So, but I would say eventually what happened is really that we came down actually just to the basic. We actually just put the projector and then use potentiometer because for sure the light would work, right? And we put the dark target as the dot. So once we have a white surrounding radius, it actually means like a senses light. So it knows how much power to provide to the motor. And we do 2D regs. Yeah, that's kind of our fail-safe final. Because yeah, for some reason the Wi-Fi and stuff, we're all still testing and it's just not fast enough, I guess. Yeah, I think we're also using like some kind of 18 mega, maybe a little bit Arduino. I'm not sure. Back then maybe is not even. Yeah, it's 2016. Yeah, so we did our presentation, yeah, for our presentation. Yeah, so yeah, I just find this quite interesting. Yeah, any questions? And yeah, that's
questions. You got another question? You got a question over here?
So, what inspired you to do this? Was this just to mimic what was already out there in nature, or were you trying to find applications for this outside of the lab?
Yeah, so I would say since this is part of actually in the art department, there's like the mechatronics department. So they actually do try to build their own expressive, we call them like expressive robotics. Some of them like try to follow humans and stuff. It's all done. And I think one of our professor wants to explore like how, the herd movement, but with robots, So we really want to focus more on the aesthetics. And this is kind of just our like research project on like what kind of technologies are there, and we try to, what kind of like algorithms or things we can do to simulate. So of course we started off with using Unity to simulate the 2D, and then once the 2D is done, then we move on to, okay, let's implement the hardware stuff, right, to make it look cool. Because after all, it's the display and presentation that matters the most, especially in art.
Another question.
Would you like to continue working on it with a larger group?
For like, I guess hobby, this is more like a hobby project, because I don't know, I'm actually right now toward trying to find a job, to be honest. Yeah, I actually recently just returned back to the US after finishing my master's. I'm actually more focusing on the UI UX design, which I find it quite interesting. So maybe eventually if this can turn into like a human robotic interaction project or things, I think I like to explore how, how humans can collaborate with new technologies, especially in different ways.
All right, Edward. Thank you.
Yeah, thank you.
All right. Well, I don't know what to say. I geeked out. Who else geeked out? Raise your hand. Nobody? Everybody? All right. I nerded out. That was awesome. It was long. It was exhausting, to be honest. But it's awesome. It's so awesome to see you guys all come out here. TJ, thank you again for coming out for Noise Bridge. Shout out to Noise Bridge. We got Robert, David, Joe, Anthony, Kevin, Yaga, Balaji, and all you guys. Thank you guys. You guys are awesome. With that said, we're going to wrap it up. What I want to do is move the tennis table, or not the tennis table, the ping pong table out of the way so we can take a group photo. Bring your robotics to the back. I want everybody in the back with the robotics so we can show it off in an awesome big photo there. So with that said, guys, until next Friday, thank you guys for hanging out at Lightning Talks at Hacker Dojo. Woo!
80% of the votes that are tallied in the U.S. election are tallied on systems sold by companies owned by brothers. It gives a new meaning to the term family values.
All right, if I get all the presenters to bring their robotics up to the backstage. Somebody want to get Cujo? You got Cujo over here? Somebody can pick up Fred. Joe? Ready to go? All right, let's get everybody lined up in the back. Let's get ready for that photo right over here. Everybody group up, group up. Come on up. Come on, come on. Come on, guys. Come on, everybody. Let's go. Quick photo, quick photo. Grouping up. We got the robotics. Where's the robot there? You guys squeeze it? All right, the front row is going to crouch down. We'll give you one row in the front that's going to crouch down. Okay, tall people in the back. All right, down on the front. All right, you guys got to move it. Okay.
Yeah, you can also pay extra.
This is a public service announcement from Summit FM and DEFCON Radio. Remember your 3-2-1. 3 hours of sleep per night, 2 hot meals, and 1 shower.
Not that like of course, like if you just say I don't want to do anything, then you're. It's just like getting into the. But after you get in, what I think you do is I wouldn't say getting in here, but after you get in, getting out is a whole lot. Getting out is really not unless it's really hard.